Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And in this video I'll be going over not only big data and public health, but now the major role of artificial intelligence that is revolutionizing the field. This is a bit dated. It's about 4 years old, 2018, 4 to 5 years old. So this goes through kind of in the abstract, discussing how AI and big data and their significance to public health is worth writing about. There's a lot going on. They highlight issues involved and describe the potential impacts and challenges to medical professionals and diagnosticians. So big data is associated with the massive computational resources needed to cope with the increasing volume and complexity of data from many sources, such as the internet and remote sensor networks. So this is there's many types of big data. It's not just limited to structured. There might be semi-structured or even unstructured. There's a lot of times in electronic health records, there's a lot of unstructured data that may be kind of interpreted using natural language processing. But data corruption by noise and artifacts, data entry errors, duplicate records, missing records, all of these could be kind of something that maybe hinders decision making by humans. Computers can do some of the things better. So then they go into describing the 5 V's, and those in some previous articles I talked about 4 V's, but in this one they want to go through and kind of review the 5 V's. So it's variability, variety, velocity, veracity, and volume. Then it goes into variability, lack of structure, consistency, and context. Variety includes audio files, imagery, numerical files, etc. Velocity, real-time processing, and very high speed of transmission. Veracity, less noise, accuracy, and uncertainty in data as much as possible. And then volume, extremely large types of data sets. So then this goes into a bit more about big data as it pertains to molecular biology and clinical trials, where DNA profiling is needed, and also keeping track of biomarkers that may be indicative of disease states in the future, and kind of early warning biomarkers. And this is then leads to targeted treatment rather than a standard approach. So targeted treatment is very much where big data and geospatial skills can kind of intersect to provide the public health context that is so important, and yet precision medicine on the other hand. But there's uncertainties in the precision of medicine approach. And it's important to keep track of those. Then it goes into artificial intelligence. Honestly, this could have been a bit more developed. There's a brief kind of treatment of artificial intelligence where big data modeling, AI models, data infrastructure. So as you can see, big data and artificial intelligence is at the center of all of this. The data characteristics up here, statistics down here, then the artificial intelligence over here, both of these, and then these are the Internet of Things that is going into creating the big data that we see. That's a very informative figure, more so than the section that it goes through. If you do have a little bit more time, you can go through that, and then it goes into machine learning, a subfield of AI. That can be used to create weight, sensitivity, specificity, and just a wide variety of things. And then vision augmentation, for instance, artificial vision or miniature television camera, so including faces, things like that. So less chances of error in any of these. And then data mining is another potential. So the list goes on, and then conclusions. The fundamentals of AI and big data have been introduced and described in the context of potential applications to data analytics in public health and medical sciences. So introducing these, describing these, it's important to understand from a public health context and a medical context. So the advent of AI and big data will change the nature of routine screening and specialist diagnostics, and perhaps even in general practice and routine pathology. So the opportunities are endless. Deeper understanding of these new technologies is required for public health and policy development by bureaucrats, politicians, and business leaders. So again, combination of AI and big data is the future. Thank you for listening.